Hey guys, my name is Sartek Cambridge, and in this video we're going to talk about how to delete a node containing a certain piece of data from a circular linked list. So without further ado, let's just get into it. So essentially we have a list over here, and if we print that list out, we see we have the elements A, B, C, and D. And what we need to do is we need to figure out how, if we want to remove like the element B, if we pass in that data into our delete function, how we can delete that node from our singly linked list. So there's two primary cases that we have to take care of. One is where the node that we want to delete is self.head, and the other case is where the node is somewhere else in the list. So let's start off with the first case, where if self.head.data equals data, then what we need to do is we need to find the last node in the circular linked list so that we have access to the previous node from self.head. Because remember, since it's a circular linked list, we need to make sure that the last node that's in the list also points to the new node that will be crowned self.head, because we're deleting the original self.head. So just to show this, if we start off declare a variable called self.head, and we initialize to declare a variable last and initialize to self.head, we can say while last.next is not equal to self.head, we can say last equals last.next. So once when we exit this while loop, we know that the element that in the variable last is indeed the last element from our circular linked list. And what we can say is last.next equals, or we can actually store our new variable. We can store cur in self.head as well. And we can say last.next equals cur.next. So what this does is this takes the current node and the last node and makes sure that the last node is now equal to the node that's to the right of the current node. And the last thing that we need to do is we need to say that self.head equals to last.next. So essentially what this does is if we have, say, a circular linked list that contains the elements 1 and 2, and then this eventually points right back to 1. So what we can say is the last node is the node containing the number 2. So we say last.next equals cur.next, which in this case would be itself, right? Because cur is 1, and then we can say self.head equals 2, right? So essentially what we're saying is that the next element is now self.head. So that takes care of that situation. Now if we can return there. If we're not dealing with a situation where we have to delete self.head, what we can say is we can initialize a variable called none, prev equals none, cur equals self.head. And what we can say is while cur.data is not equal to data, we can say cur equals cur.next, right? And what we also need to do is while cur.next is not equal to self.head, right? So essentially what this takes care of is the fact that we want to make sure that we don't have a situation where we go through the entire circular linked list and there's not a node that we need to delete, so we keep looping through. And one thing that we need to note is that because we're saying cur.next cannot be equal to self.head, there might be a situation where the very last node is the node that we need to delete, but we never execute this code. And so we're gonna need to take care of that situation. So what we can do is if cur.data equals data, then we know that we've exited the loop, because indeed like the current node actually has data that's equal to the data that we passed in up here. So what we can say, and one good thing that I'd also take care of is because we're saying that cur.next is not equal to self.head, because of that, now we know that even if it is the last node, let's say we exited the loop because we're at the last node, and the last node's next pointer is equal to self.head, right? In that case, we don't actually know if its data element is equal to the data element that we passed up here, but because of this check, we can ensure that that actually is the case. And if it is equal to the data element that we passed in, then we can execute the code within this if statement. So what we can say is prev.next equals cur.next, and essentially what this does is it removes cur out of the circular linked list, and we can even say cur equals none. So that should take care of that situation. And if we do cll.delete a, we can see that it does indeed delete the letter A, and now we have a new self.head. And if we do cll.delete b, we get an error that says prev equals. Small mistake. We need to say that prev equals cur. So as we're updating cur, and we move forward in the circular linked list, we need to make sure that we're updating the prev pointer. So there's actually some sort of node that we can appoint the next variable to. And the good thing about this is that because we already checked that self.head is if self.head.data is equal to the data that we passed in, we know that over here prev will be some variable. It will at least be self.head, because we know that this will not be self.head itself. We already checked that up here. So if we run this one more time, we can see that we deleted B from our list, and now we just have the elements A, C, and D. So with that, I hope you guys learned something in that video, and until next time, peace.